Hi, this is Mrs. Rodriguez with another lesson video. Today's lesson video is on adding fractions. What you need to find is your least common multiple, okay? Your least common multiple. That means the smallest number that both 3 and 5 multiply into. And the way I like to do it is I draw my little table, okay? And multiples would be times 1, times 2, times 3, times 4, times 5, okay? And we're going to do that for 3 and 5. So 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12, 3 times 5 is 15. Then we do it for 5. 5 times 1 is 5, 5 times 2 is 10, 5 times 3 is 15, 20, and 25. Now the goal of this is we have a list of multiples for both numbers and we're looking for a matching number for both. So do they have any numbers in common or that are the same? Remember, common means the same. And they do. We have 15 here and 15 here. So that means our least common multiple, our LCM, equals 15. And you might be thinking, well, why is that a big deal? That's a big deal because your least common multiple is going to be your denominator. So that means the denominator is going to be 15. Okay, so you want to find the least common multiple because that ends up being the denominator you need for both of these fractions in order to add them together. Now, some of you might have looked at 3 and 5 and said, okay, a number that they both multiply into 15, right? You might have been able to do it in your head. So remember, I'm showing you how to do this with the table so that if you get numbers you're not sure about, you know how to still figure out what your least common multiple is supposed to be. Now, if 5 spaces, if 5 multiples was not enough for my chart and I needed more, then I would have just added it on. Okay, so try the first 5 multiples for whatever numbers you're working with, and if it's enough, great. If it's not, you can always add on to the table. All right, so now we know that 15 is supposed to be our denominator for these two fractions. So I'm going to go ahead and take these two fractions, 2/3 and 4/5, and now I know that I need to multiply both by a giant 1 that gives me 15 as the denominator. Okay, so we found the least common multiple. That tells us what denominator we're supposed to have. So now I need to multiply by a giant 1 to convert these fractions. Now, why do we call them a giant 1? We call them a giant 1 because these fractions, whatever fractions that we come up with, or whatever numbers we come up with, so for instance, in the first case, 3 times what number gave us 15? 3 times 5. Okay, well, if 5's the denominator, we call this the giant 1 because whatever you multiply on the bottom, you do the same on the top. And 5 divided by 5 is 1. And if you'll recall, 1 times any number is the number. So by making our giant 1, 5 divided by 5, it actually just equals 1, right? Because 5 divided by 5 is 1, and 1 times 2/3 is 2/3. We didn't change anything. That's why we want to multiply by our giant 1, because we want these fractions to be equivalent fractions. We don't want to change the fraction value. We just want to change the fractions so that they can have a common denominator, but we're looking for equivalent fractions. And if you don't remember what equivalent fractions are, please watch the video on equivalent fractions. So we're using giant 1s because they equal 1 and they don't change our fractions, they just give us equivalent fractions. So now I look at 4/5 and I go, okay, what times 5 gave me the 15? It was 5 times 3 that gave me the 15. So whatever's on the bottom has to go on the top because it must equal 1. So 3 divided by 3 equals 1. And 4 times 3 is now 12. 2 times 5 is 10. So now we've successfully converted our fractions using the giant 1 to get equivalent fractions, meaning fractions that are equal. Okay, 10/15 is equal to 2/3. 12/15 is equal to 4/5. Okay, 2/3 and 4/5 are just the simplified versions of these two fractions. So now that we have our two equivalent fractions and they both have a common denominator, we can go ahead and add them together. Okay, 10 plus 12 is 22 over 15. And I can simplify that by thinking, well, how many times, this is an improper fraction, 22 is larger than 15, so I can think to myself, how many times does 15 go into 22? It goes in once. What's my remainder? Well, 22 minus 15 is 7, so my remainder is 7, and the denominator stays 15, and I get 1 and 7/15. Okay? So that's the giant 1 method. Your goal is to convert or change the fractions by multiplying by a giant 1 to make equivalent fractions that will now have a common denominator so you can add them together. Okay? And the fractions now have the same parts, right? 1/15 and 1/15 are equal. So if we have 10/15 on one side and 12/15 on the other, we can add them together. As always, if you have any questions or need additional assistance, feel free to make an appointment with me for office hours.